Hello and welcome. In this live session, we will learn how could we analyze and retrieve the protein secondary structure. So in this lab session, you will learn how could you submit and analyze the protein secondary structure by using online tools, and how could you retrieve the information about the different components of secondary structure like alpha helices, beta sheets and strands and coils. So there are so many tools and online servers available for the secondary structure prediction. But in this session, we will learn how could we use the GOR4 tool for the analysis. So let's now understand how secondary structure prediction can be performed by using GOR tool. GOR basically stands for Garnier, Osgothorpe, Robson. These are three scientists who came up with this tool used for the prediction of secondary structure. It basically includes both the information theory and Bayesian statistics for the prediction. The accuracy of GOR method has been improved from about 55% up to 64.4%. And this method has advantages over other methods like neural network based methods or nearest neighbor methods, that it clearly identifies what is taken into account for the prediction and what is neglected. So this methods provides estimates of probabilities for the three secondary structures at each residue's position that can be useful for further application. And this tool is freely available for the non-commercial users. So let's now understand this tool by some practical example. To get into the website, you just have to simply write the GOR4 tool on Google or just click on the link mentioned above, then you will be redirected to their home page. You just have to put your query sequence over there and then click on the submit button. Just after a few minutes, you will be redirected towards your result page. So this is the result page. As you can see over there, this is your query sequence which you have just pasted, and the length of your query sequence is about 483 amino acid residues. These different symbols represent the helices, beta coils and sheets. Like the HH represents the alpha helix. As you can see over there in your sequence, these H, which are in blue color, represents the alpha helices. You can also get information about the subtypes of helices like 3, 10 and pi helices, that has been represented with the G, G and I respectively. If there is any beta bridge between the two amino acids, you can get the information from that as well, that has been represented with a small b. Then you can get also the information about the beta strands and sheets, that has been represented with the capital ENT respectively. And the C represents the random coils that have been present in your query sequence. You can also get the information like you have 33.33% of alpha helices in this query sequence, and you have 21.53% the beta sheets are like 21.53% of the beta sheets are present over there, and 45.13% of random coils are present in your query sequence. So in this way, with the help of GOR4 tool, you can get the information about the components of secondary structure, about the subcomponents of helices, beta strands, sheets, and random coils. You can also get the information of these helix, sheets, and coils in some graphical form. Like in this graphical representation, the blue line represents the helix, the red with the sheet, and the purple with the coil. These represents the length of your amino acid residues, and the different color represents the helix, sheets, and coils. So in this way, you can use this graphical representation of your secondary structure in your research or in your thesis or in your any other work. So what you're going to do is just simply paste your query sequence and click on the submit button, and after that you will get all your required results of your secondary structure, which you can be predicted and retrieve, and it can be used in your research or in thesis or for any other purpose. Thank you.